Okay, Chloe, we are on, what is this, R6? Or is this R6? I don't know. R6, yeah. We started this on Wednesday when I was gone. Was Chloe gone also? No, Chloe was here on, okay. So we are now on example 6 on R6, okay? And here we go. On this problem, she was gone on Wednesday? Oh, okay. So, Chloe, if you have not yet watched the beginning part of R6, it is on Google Classroom because I was gone. So this is on your email, but the other one's on Google Classroom. Okay, all right, we do not want to have eyes in the bottom. That's what R6 is getting at. It's considered to be like improper, basically, right? So do you guys remember how, like, let's say we have 4 over 2 minus the square root of 5. Do you remember how we got rid of the square root of 5 in the bottom? Like, how do I rationalize that? Have we done that yet? How do we get that thing to go away? How do I get the 2 minus the square root of 5 to go away? 2 plus the square root of 5 and 2 plus the square root of 5, right? And then I would FOIL and do all the things, right? Right? So it's kind of the same thing. You want me to keep...
It's like taking it
Yes, this guy reduces to be 1, so it's not changing the value, it's just changing what it looks like, right?
Wait,
okay?
Did you mean to have it be an addition?
Yes, because you want it to be the conjugate. Because it's the conjugate, those two middle pieces cancel out, right? Okay? All right, so that's what we want to have happen here. I can have eyes in the top. That's fine, but I don't want to have eyes in the bottom. So 3 minus 5i, we've got to do 3 plus 5i. Yep, those are conjugates. Okay? It doesn't cancel completely. So what's going to happen on the bottom is 3 times 3 is 9. 3 times 5i is plus 15i. Negative 5i times 3 is minus 15i. Okay, and what is, this is the hard part, what's negative 5i times positive 5i? This will be negative 25i squared. But I squared is negative 1, so it becomes plus 20. Oh, gosh. So it becomes plus 25, right? This is like negative 1 times a negative 25, so it becomes plus 25. Got it? Let me write that out better. Boop, 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 boop. Negative 1, so this cancels out to be plus 25. Maybe that's more helpful. Okay? All right, so the bottom parts cancel out these two, and so my bottom is 34, is my whole bottom. Okay, now let's do the tops. The tops are not going to cancel because they're not conjugates. So I have 8 times 3 is 24. Oh, gosh, why am I erasing? I don't know. 8 times 3 is 24. 8 times 5i is plus 40i. 2i times 3 is plus 6i. And what's 2i times 5i? Plus 10i squared. But I squared is negative 1, so that's going to become minus 10. All right, now let's put stuff together. 24 minus 10 is like 14. And 40i plus 6i is 46i.
It's divisible for sure by 2.
Yes, for sure by 2. I don't think any more than that because 14 would just be 2 and 7.
Yeah.
Right? Okay, so we divide by 2. This is 7 plus 23i over 17. Is divided by 2. Now, here's the deal. I would accept that as a final answer, but they ask up here, then write the result in the form of a plus bi. Okay, so kind of like we just did on that last homework problem that you just asked, whatever. Okay, they want you to separate it out into the two pieces. So it will be 7 over 17, that's the a part, right? Plus 23 over 17i, that's the b part. You see that? A plus bi. Yeah, that is a little silly, but that's how they have you write it. Sometimes, yeah. Sometimes I will probably take this as a correct answer, but just so you know, like on like maps testing, let's say, or whatever, you might see it like this, and you're like, what the heck? Well, that means the same thing. So, FYI. Okay, good? All right, so i's in the bottom are bad. Multiply by the conjugate and get him gone. Okay? All right. Solve the equation by applying the square root property. All right, how do we do this? Not yet. Let's subtract 36 because we have to isolate the thing that is being squared first. 2y squared equals negative 3. Kind of like you have to isolate the square root. You have to isolate the square.
Divide by 2.
Nope. Now we're going to divide by 2.
So then you just have y squared.
So y squared equals negative 18, right? Now we're going to take the square root. Okay? All right, we got some weird stuff going on here. This is just y, right? We took the square root.
So it has to be plus minus.
So it has to be plus minus, for sure. Okay? We know it's going to have an I in it, but now let's break down the 18, right? Okay, what can you take the square root of that goes into 18?
3, 9.
9. 9 and 2, right? So the square root of 9 and the square root of 2, the square root of 9 is 3 square roots of 2. So 3 square roots of 2i. Some people write it like 3i square roots of 2. I don't know that which one I necessarily prefer. Either one of those will work. I don't care. I don't care. Yeah. Yeah. You had a lot of these? Yeah.
I had decent amount. I also had a lot of triangles, and there was a lot of proofs.
Really?
I had like 3 proofs.
And
Interesting.
I think I got those.
Yeah?
I had like sine, cosine, tangent, and I
Nice.
think I was doing sine when I should have done tangent.
I had
Yeah?
some proofs, and then I had some like weird shapes that had all the like bases and heights and stuff like that. And I
Yeah,
had
it
a
made
lot
me
of
find like
eyes.
volume a bunch of times.
I didn't get any volume.
I got 2
I
volume.
They were like weird shapes.
I had 1 volume.
Huh.
It was
Like the one
the
with the
triangle,
N.
the pyramid.
I did.
Yeah,
I had
I
one with
agree.
N.
The n cube, and then the other one.
Huh.
Like 3 times, or like to the 3rd power.
Oh,
Do
there you go.
ever have the same questions as someone else?
I don't. It may be, but I don't know.
I got the volume.
Like
of
never
pyramid.
the
It's
whole
not the
test.
same
The whole
order,
test
because,
is never
like,
the same. But you might have some of the same questions. Yeah.
I got a lot
Does it
of.
progressively get harder?
What?
Does it progressively get harder?
Yeah, well, yeah. So it is, what do they call it? It's not a summative test where like everybody, like it spits out one answer at the end. It like tracks your progress. So it like gives you an easy question. If you get it right, it gives you a harder question, right?
So
If
how
you
does
get this one wrong, it gives you an easier question.
How does
Then
it
it
score you?
like it tracks. So like everybody starts off at like a 300, whatever, like for points, I think, or something. Or maybe you start off at 0. I'm not really sure. But it starts you off somewhere, and then like it gives you a question. So let's say it starts you off at 0, right? Okay, and you get a question right. Okay, then you're at 10 points or something like that. If you get a question wrong, you stay at 0. Okay, then if you get this question right, now you're at a 20, right? And if you get this question wrong, you're at a 15. I have no idea. But then it keeps going, like it tracks your points or whatever on. I don't know.
Do you think it's an accurate test to portray our knowledge?
I think I like it better than just a straight test because it does like cater to what you kind of know. The only problem is sometimes you'll end up with like 5 of the same type of question, you know, and it should give you like kind of a little bit in every area. But the fact that it does test like the same number of number sense, the same number of geometry questions, the same number of algebra questions, like that is good. And I think I like that it tracks your, like gives you easier questions if you don't know, it gives you harder questions if you do know, you know, that
I
type
got a
of thing.
lot of how tall is this tree based off. I got a lot
awesome.
Of those.
So
And
So
so much
good to,
factoring, like this type of factoring.
Yeah, nice. Okay, this one says they want us to use the quadratic formula, and I do not want to do that yet.
Okay. Then let's
Gross. Look at our bottoms here. 10, 5, 10.
Let's just.
Let's find a common denominator, but here's the deal. Yeah, it's like having a common denominator of 10, right? So this is 3 over 10x squared, right? If we make this one a denominator of 10, that will be negative 4x, right? Because we'd have to multiply by 2 on each one of these, right? This is 7 over 10, right? And we would have to take 0 times 10, but that will still be 0 over 10, right? Times 10 on the top and times 10 on the bottom, right? Okay? But now what?
Why couldn't figure out which
Why
each
couldn't
one?
you do?
We don't have to figure out which each one's.
We did. We did have to find what each one needs, right? Like, but this one already had 10, this one already had 10. So the 5 needs to be multiplied by 2. So we multiplied the 2 by 2. Does that make sense? We already kind of did that in our head. 0 over 1 needs to be multiplied by 10. So we multiplied 0 by 10, which is still 0. What?
Why couldn't you do quadratic with this?
You can, but it's disgusting. And I would rather do quadratic with 3x squared minus 4x plus 7
Yeah, that's what I.
equals 0.
Right
Yeah, like now I can do quadratic. Yeah. But get rid of those ugly fractions first by like doing the common denominator thing. Okay, now quadratic formula, negative b plus minus square root b squared minus 4ac all over 2a. All right, here we go. What is negative b going to be?
4,
Positive 4, right? Plus minus square root. What's b squared?
16,
Is it positive 16 or negative 16?
positive.
Positive 16. Minus 4 times a is 3 and c is 7. All over 2 times 3. Okay. All right, are we good so far? Okay, hold on. What's 4 times 3 times 7? 4 times 3 is 12. 12 times 7 is 84. Okay, so we're taking 16 minus 84, which is a huge negative number. Like negative 68. Okay, so right now what we have is 4 plus minus the square root of negative 68 all over 6. Okay, we can see from like right now that that's going to end up with an I, right? So let's get rid of that negative and let's do an I, okay? Now, we cannot divide by 2 yet because the 68 is trapped underneath. So let's see, is there anything that goes into 68 that we can break down? Like 4 for sure goes into it. Is anything bigger? 16. Does 16 go into 64? Nope, 16 goes into 64. So I think 4 might be the highest. 4 and 1, 7. 4 and 17. Is that true? And 17 is prime. So this guy is 2 square roots of 17 plus minus 2i square roots of 17, or however you want to write that, all over 6. Okay, I'm pausing. Okay. All right, now you can divide each one of these by 2, right? So if I divide 4 by 2, that's 2. If I divide 2 by 2, that's 1. If I divide 6 by 2, that's 3. So final answer, 2 plus minus I squared roots of 17. I don't need the 1 there. All over 3. Beautiful. Did they say they want it in the form of a plus bi? How would you put that in the form of a plus bi, by the way? 2/3 plus minus
I square root.
the square root of 17 over 3i is how they'll probably write it.
Oh,
So if you see it that way, just FYI, or if you can put the I in front, it doesn't really matter. Whatever. Okay, there is that. Good? Oh, the discriminant is easy. I love the discriminant. Okay, write the quadratic formula at the top of your page. Negative b plus minus the square root of b squared minus 4ac all over 2a. All right, this is the quadratic formula, right? The quadratic formula. And quadratic formulas are used to solve quadratics that are in the form of ax squared plus bx plus c, right? Equals to 0, right? What is the quadratic formula? Like, what does this thing tell me? Where it crosses the x-axis. It plugs in a, b, and c, and it tells me where that parabola, right, is going to cross. And sometimes it crosses at 2 places, like this, right? Okay. Sometimes it only crosses at like 1 place, where the vertex is on the x-axis. Don't write this down yet.
no, I'm just putting.
And sometimes it doesn't cross, like it's levitating, right? And these could be the same but flipped down, right? Like he could be down here as well instead, right? So it doesn't necessarily have to be flipping up, but that's how that works, okay? Now, in this quadratic formula, you can plop stuff into here, and it will tell you which one is which, okay? This thing alone will tell you which one of these 3 things are happening. Okay, let me give you an example. Okay, let's say, put these off to the side over here. B squared minus 4ac is less than 0. Okay, let's say I'm making these numbers up, 2 plus and minus the square root of negative 4 all over 3. Let's go 2. We'll go 2 again. We'll make it nice, okay? All right. Do we see how this works? Okay, here's my example. If b squared minus 4ac, which is the stuff that's underneath it here, if it is less than 0, in other words, if it is a negative number, if my b squared minus 4ac, the stuff underneath the squared is a negative number, we're going to end up with what here?
Minus 1.
There's a frog
There's
on
a
your
frog
window.
on the window.
No, there's not.
Where?
Yes,
Come
it's
and
a
look,
big
it's a frog.
There's a frog.
It's
It's
a
on my
bull
window.
frog. Megan, look. It's not like a toad.
Oh my goodness, he's so cute.
Here's the TV's blocked.
He's right there.
Actual frog.
He's stuck on my
It's like a
window.
Actual
away.
cool frog.
He's so
Can we
cute.
capture it?
I don't think you can without scaring him, unless you go outside.
What?
He's like a tree frog or something, you know?
Can you make it go away?
Why? He's not gonna hurt you. He's not gonna jump through the glass, Megan. Oh my gosh. Chloe's hearing this right now and she's like, what in the heck?
And we're gonna like catch it and then chase me with it and then I'm gonna shirt crack.
Nah. All right, whatever.
Frogs.
Megan scream on the video.
Okay, so if this 4 is negative, he will reduce to be, what's the square root of 4, by the way? 2, but what's the square root of negative 4? 2i all over 2. Okay, you just told me the quadratic formula told you what? Where it crosses. It is crossing at an imaginary place. If that stuff underneath of here is negative, it's crossing in an imaginary place. So what does it look like? It's not crossing. So it's either going to look like this or it's going to look like that. I'll just write the top one, right? So we can tell from the discriminant alone what's happening. True?
Wait, do you know which way it'll be? Like?
We don't unless we look at the equation like this guy. I can tell from here that he's going to be a frowny face, or that he's going to be a smiley
If
face.
it's negative, it'll be front.
Yep, if it's negative in front of the x squared, it'll be a frowny face, so it'll be down below. If it's positive, it's going to be a smiley face, so it's going to be up above. Weird. Okay, next example. Let's say I have 2 plus minus the square root of 0 over 2. In this case, my discriminant is 0, right? The stuff underneath of the square root is 0, okay? What is the square root of 0? What's the square root of 0? What do you take times itself to get 0? 0. This is 2 plus and minus 0 over 2. Okay, that gives me 2 answers. What is 2 plus 0 divided by 2? 2 plus 0 divided by 2. 1. What is 2 minus 0 divided by 2?
1.
Also 1.
So it's just gonna touch at one place.
So this, when he is equal to 0, he has only one place he intersects, and here it is at 1, right there. So when your discriminant is 0, he's only going to touch at one place. He's only going to have one solution. Got it? Last one. Let's say, I'm doing the same equation every time, but I'm just switching out the discriminant. Okay, here's your example. 2 plus minus the square root of 4 over 2. Okay. What is the square root of 4? 2. All right, what is 2 plus 2 divided by 2? 2. What's 2 minus 2 divided by 2? 0. So when my discriminant is a positive number, or in other words, greater than 0, he is going to touch at 2 places, 0 and 2, and he's going to do this. Now he could be a frowny face also, touching at 2 places. But that is what's going to happen. So if your discriminant is positive, he's going to touch at 2 places. If he's 0, he's going to touch at 1 place. If he's an I or a negative, he's going to touch never. Got it? That's what your discriminant is.
Okay, so it's not that bad.
Not so bad, not so bad. Okay? All right, use the discriminant to determine the number and type of solutions for each equation. Okay, I'm just going to tell you the number of solutions. Don't worry about the type. I guess you could say imaginary, whatever. Anyway, all right, so here we go. What is the discriminant, by the way?
B squared minus 4.
B squared minus 4ac, not the square root over top of it, just the stuff that's underneath, right? Okay, b squared minus 4ac. All right, what will b squared be? Negative 3 squared, which is 9, minus 4 times a is 5, and c is 1. So this is 9 minus 20, which is negative 11. All right, Imagine that negative 11 is now underneath of that square root, right? The square root of negative 11. What's going to happen there? It'll have an I, which means he is going to,
The first example where it won't touch.
where it won't touch, right? He's touching that line in an imaginary place, which means he's not touching. No solutions. Zero touches. So if you want to just do that, tell me the discriminant and tell me how many solutions he has. He has no solutions. None. 0 places where he crosses. Good? Okay, B.
You need to move it.
Ooh, we got to move everything to one side.
2x squared.
You want to move it to the right side or to the left side? I want to move this stuff over here because I always want my x squared to be positive.
Minus 3.
But if it's not, then it just means it'll be like that frown face.
Yeah, maybe. Oh my gosh, that's a bell already. Whoa! We have short periods today. All right, we'll start with B tomorrow. Goodbye.
Oh, what count?